The bipartite graph models the key relations in many applications such as customers purchasing items, legislators voting for bills, and faults occurring in vehicles. Real-world bipartite graphs may contain tens of thousands or even more nodes and edges with additional attributes, making it a challenging task to develop effective explorative analysis tools for such data. We propose an efficient co-clustering algorithm for interactive visual analysis of large-scale bipartite graphs. Given a bipartite graph, the algorithm identifies an optimal grouping on the two sets of nodes simultaneously based on information theoretic criteria. With the grouping information, we design an adjacency list-style visualization to summarize the bipartite relation. The visualization represents the clusters on one side as rows and their outgoing connections to the other side as colored blocks, stacked from left to right. Different colors represent different clusters on the other side. The height and the width of the blocks are proportional to the number of nodes in the two clusters. The field height of the blocks is determined by the density of the edges. The blocks are sorted from left to right by the density. Next, we demonstrate the ViBr system, which tightly integrates computation, visual representation, and user interaction. In ViBr, the summary view shows the aggregated bipartite relations as visual adjacency lists. Users can filter the blocks by density and sizes of the node clusters to focus on the most significant patterns. We also provide adjacency matrix as an alternative view. Users can select an arbitrary node attribute to split the visual summary into small multiples. Double-clicking on any of the blocks brings up the detailed view. It shows the original data in a matrix visualization. The co-clustering algorithm is triggered again to group the rows and columns to reveal the next level of internal structure. Users can brush on the matrix to inspect the detailed information of the related nodes in the two data tables. The left panel shows the schema of the dataset, provides overviews of attribute panels, and efficient controls for data filtering before starting the analytics pipeline. Next, we demonstrate two example usage scenarios with real-world data. The first usage scenario is vehicle data analysis. The main task is to understand the fault occurrence patterns in vehicles to enable experience-based repair and large-scale troubleshooting. The analyst first loads the data into the system. She first filters the data to a particular model and runs the co-clustering algorithm. After filtering out the blocks with low density and small size, she observes several large clusters of vehicles with different combinations of faults. Some groups have a unique set of problems. Some groups share a common set of faults but differ by some additional ones. Given an overview of the data, the analyst would like to further understand whether the fault patterns are associated with a particular subpopulation that share the same properties. She tried several attributes of vehicles to separate the overview into small multiples. After some iterations, she finds out that a group of faults mostly occur in vehicles with a particular type of engine. To confirm the findings and obtain detailed information, she opens the matrix view, brushes through the entries, and reviews the details in the data tables. The second usage scenario analyzes the roll call vote record in the House of Representatives in the United States in the 115th Congress. The dataset records individual legislators' votes on each subject. Analyzing the voting records helps understand the political dynamics in Congress. The analyst loads the data and runs the co-clustering algorithm. In the overview, different colors represent different clusters of bills. Separating the overview by the representative's party affiliation shows that the two parties indeed have a very different set of favored bills. In both partitions, the analyst noticed high-density green-colored blocks. She double-clicks one to open the matrix view and review the details. Most of the subjects are related to on motion to suspend the rules and pass, which refer to the act of quickly passing non-controversial bills. On the other hand, the subjects mainly supported by the Democrats are mostly related to these categories. 1. Send back the proposal for amendment, and 2. Amendment of bills. The Democrats' support on amendments is a clear reflection of the bargaining process in the legislature. As the minority party in the House, the Democrats may find the bill drafted by the Republicans far from their ideal policy position. Through negotiations in the House, the Democrats may propose changes to specific articles in the drafted bill through amendments, such that their interests and preferences are represented.